for riveted joints tutorials and examples. Yeah. Okay, so now let me explain what is in this question here. Okay, find the efficiency of the following riveted joints. Single riveted, first part is for a single riveted lap joints, yeah, with 6 mm plates. That means this is the thickness, with a 20 mm diameter rivet, which has a pitch of 50 mm. So there are two conditions, A and B. B is based on double riveted lap joint. So the difference between single riveted lap joint and double riveted lap joint, remember the N, the number of rivets. For single riveted must be multiplied by 1. For double riveted must be multiplied by 2. Okay, and then with the thickness of 6 mm, diameter also the same, 20 mm. The only thing is the difference between part 1 and part 2, A and B, is first is single rivet, part B is double rivet. And then the pitch for part 1 is 50 mm, for part 2 is 65 mm. So for both the condition, the permissible tensile stress in the plate is 120 megapascal, and then the permissible shearing stress in the rivets is 90 megapascal, and the permissible crushing stress in the rivets is 180 megapascal. So these are the data that is given: the thickness of the plate 6 mm, the diameter of rivet 20 mm, tensile stress 120, okay, and then this is in megapascal, this is in Newton per millimeter square. So megapascal can be also mega Newton per meter square. So the shear stress in the rivets is 90 megapascal or 90 Newton per millimeter square. Crushing stress, that is this, is 180 megapascal or 180 Newton per millimeter square. So first part, okay, you have to find the joint efficiency. This is the efficiency, okay? You have to find the joint efficiency based on the data that is given in part 1. So first you have to look into, now before you can calculate the efficiency, you have to calculate the tearing resistance, the shearing resistance, and the crushing resistance, okay? All the three strengths, okay? The tearing strength, the shearing strength, and the crushing strength. Why you need to calculate? Because you need to choose the minimum, the least of between these three forces or these three loads or resistance. Okay, we know that the tearing resistance, this is the formula, okay, for tearing of plates, where P is the pitch, D is the diameter of the rivet, T is the thickness, and this is the tensile stress 120. Okay, so it's up to you whether you want to use Newton millimeter square or mega Newton per meter square. So since you are using everything in millimeter here, where the pitch is in millimeter, the diameter of the rivet also you use millimeter, the thickness of the plate also in millimeter. So therefore, it is advisable that your 120 make sure is also using millimeter square. So you got a strength, or that is the force, 21,600 Newton. Okay, so remember your stress is in Newton per millimeter square. So this 50 minus 20 times 6 is in millimeter square. So Newton per millimeter square times millimeter square, you get Newton. Okay, so that is 21,600 Newton. That is for the tearing of the plate. Now for shearing of the rivets, okay, remember we have pi d squared over 4. That is the cross-sectional area of the rivet. Okay, then you need to multiply by the stress. So remember, if the stress you are using millimeter square, so make sure the diameter here also must be in millimeter. So therefore, from this you got millimeter square, pi d squared over 4, you got millimeter square, times 90 Newton per millimeter square here, you get 28,278 Newton. Then based on crushing resistance, okay, this is the formula that we use for crushing, but D is the diameter of the rivet, T is the thickness, sigma subscript C here is the crushing stress. So 20 times 6 give you millimeter square, then times 180 Newton over millimeter square, so you get a force of 21,600 Newton. Okay, so you have to choose the least between the PT, PS, and the PC. That means the tensile resistance, tearing resistance, the shearing resistance, and the crushing resistance. So you have to choose the smallest one within the three values. So that is 21,600. So we know that for unriveted or solid plate per pitch length, if you want to measure the strength of the unriveted or the solid plate, okay, that means per pitch length, is per pitch length. So that is why you take pitch multiplied by thickness. The pitch multiplied by thickness gives you the cross-sectional area of the plate per pitch length, per pitch length. Then multiply by tensile stress, because you are comparing it with tearing, tensile stress. Okay, so this is the area in millimeters square. 50 is the pitch, 6 is the thickness. This gives you millimeter square times 120 Newton per millimeter square, so you got 36,000 Newton. So you pick up the list, that means the smallest strength or the smallest force among the three. So that is what you have chosen, 21,600. Okay, 21,600. Okay, so you can actually check, okay, on your own, especially when you do an assignment based on this. Okay, you want to, okay, check whether 60% is the best value or not. Then you can put all the three values. First, you can put the tearing strength of the plate. Then you can put the shearing strength of the plate. And then you can put the crushing strength of the plate. Divided by the strength of the solid plate. Okay, so that will give you three different value for the efficiency. Then you can choose from there, and then you can comment, okay, why you pick up the less, that means the smallest. Okay, if let's say for when you are required to do it as in assignment formula. So okay, you can check all the PT, PS, and PC. Okay, check which one will give you the best efficiency. Okay, so the second part is based on a pitch of 65 and number of rivets is 2. Okay, number of rivets is 2. But then when you refer to tearing of plates, there is no number of rivets taken into consideration. That means you don't need to multiply by 2, that is n. Okay, so based on the pitch of 65, because the pitch, okay, for the second part and the pitch for the first part is different. So you got 32,400 Newton for tearing resistance of the plate. And then for shearing resistance, again here, okay, the diameter is the same as the previous question, previous part, okay, but the number of rivets becomes 2, okay, because it involves, okay, the shearing of 2 rivets. Okay, it is not double shear, okay, it's shearing of 2 rivets. Okay, so the n should be equals to 2 because you are looking at double riveted lap joint. So that is why a 2 here. The previous one you don't have the 2. Okay, so you've got 56,556 Newton. Then for crushing also you need to include the n, that is number of rivets, that is 2. So you've got 43,200 Newton. So among these three values here, okay, you have to choose the smallest one, that is 32,400 here. Okay, so you can actually put in all the three values, check one by one, and see which one gives you the best efficiency. Okay, but then okay, these questions here, in order to solve this question, always we pick up the smallest among the three values lah. Okay, the smallest among the three values. For this part is 32,400. If let's say, for example, you are doing such questions when you have to hand up your assignment and all those things, okay, usually you have to check each of them and then put your comment, okay, and then comparing, okay, part 1 and part 2, okay, part 1 the efficiency and the part 2 efficiency, see which one give you the best efficiency. Okay, class, fair?
Yeah.
Yes, sir.